Can I change that into a different form that's more useful in life in other circumstances, or in real life circumstances what's going to happen, we're going to not see it necessarily written that way, we're going to see it written in a different form. This is all about getting the different form. What can I do to any exponential anywhere, anytime? So you're sitting there, you don't know what you're doing, say, and you go to P to T, and you say, I write down the same thing. And I times it by how much? 0.03. Now, let's talk about this for a second. We've already learned that this number here is called what? You know how to put words on it? Starts with I, N, I, initial value. In other words, the start. But the start's not necessarily a start, that's what they call initial. Like if we said, ready, set, how many people are in our school now? You go from there. So that's a start, but we don't call it start. What do we call it? Initial. So if we say right from this moment, how many kids are in this school today? Look from there. What's this one called then? Starts with G. Growth rate. And how will we normally talk about that growth rate?
As a percentage.
Yeah, 3%. And by the way, you could have it written as 3 over 100 and it makes people up. So we'll look at that in a moment, do some of those. So what have I got now? I've got what we started with times by that thing there. So all I've got is I've got what we started with times by 0.03. And we talk about that as 0.03p. And if I did it with letters, now my mentor years ago said, do everything without letters first. It's got enough letters in there. And then show it with letters. So this is actually what we call, that is K, the growth rate. Now here's our new formula. The rate of change of the population with respect to time is a proportion, the rate at which it's growing is the proportion of what we started with. So when you see a question written like that, how do we get the question done? This is showing you why it works, okay? We write that as P equals P naught e to the KT. So if we started with one of those, so let's get away from the K's for a moment. So if I had a question that said this to you, 0.03, what's it doing? Growing at 3% of its population per week, per month, per year. So if Perth was growing at 3% at the moment, that's what we're saying. It's going to be 3% bigger next year. So we can go back to that one and we can say it was 3% bigger there, or we can say it's 3% bigger there. So how do I do that question? I go P equals, and I knew that it was 1,000 initially, e to the 0.03 t. So why have I done that and come back to there? So you can see where that formula comes from. Quick one. If I go to the m dt, I've got 3 e to the minus 0.08 t, so that all stays the same, which is the whole thing about differentiating e's, stays the same. And I'm going to times that by negative 0.08. So if we go back to the question, and this would be like saying 3 kilograms of uranium or whatever it is you're going to talk about, and that's our initial value. How much is it going down by? Down by 8% per hour, per minute, per year, per 100 years. Doesn't have to be any particular time. So what are we back to? Our rate of change of the mass is 0.08, in other words 8% of the mass. Let's have a look what's going on here. Remember when I first did this years ago, I'd have trouble with the fact that this was a P. I kept on going to write T. It's compared to its population or it's compared to its mass. So what do we do now? We walk in and give you a question and it says the following. Population. Do we make up an unknown name? Think of a name. What? Did you say Gigantua? Gigantua. Let's do it. The population in Gigantua is 13.7 million. We're going to make it pretty big. Actually, Gigantua will probably be 23.7 million. Population in Gigantua is growing at say 2%, and we go per annum. Or instead of saying at 2% per annum, we can say the population over time of Gigantua is growing at 0.02 of its population. So come along, I'm going to tell you that. This cries out that we're doing exponential. So how do I write that using an exponential? P, and I'm going to write it fussy for a moment. P naught e to the kt. So what's P naught? 23.7 million. And yes, I can put millions, I don't have to put a lot of numbers in. And E is 0.02 time. Now if I said to you part A, what is the population expected? Remember, it's all expected to be after 1 year. Of course you could do after 10 years and do whatever you want. So we've got P is 23.7 e to the 0.02 times 1. So I don't even have to write the times 1 down. Put in your calculator and write the answer down. What makes this different to what we did before? The way they express the question, which is this thing here.